Welcome back to the exam walkthrough from the circular motion playlist. We're going to be doing 2021 Jan Unit 4, question number 10 and question number 15. So it says the website states the radius of the orbit of the moon around the Earth is increasing by a small amount each year. However, the time period of the orbit remains constant. They want us to tell which row is correct and which statement matches whatever they have written above. So first, in the first column, we have angular velocity of the moon and speed of the moon. Now the equation which links both of this is going to be V is equals to R omega. Now omega we know is equals to 2 pi by t, where t is the time period. And they've told me the time period remains constant. If time period is constant, that means omega will also be constant because omega is dependent only upon the time period. So our omega is constant. So if our radius is increasing and the omega is going to be constant, that means our speed must be increasing. So the correct option is B. So in the question number 15, a poi ball is attached to a person's hand by a cord. A child makes the poi ball undergo a circular motion on a vertical plane as shown in the photograph. The poi ball moves clockwise in a circle of radius r, center O with a constant speed v. Diagram shows two position A and B of the poi ball, and they want you to derive the centripetal acceleration equation. We have done this question in the third exam walkthrough, I think. So I want you to go there if you want to clear up the basics. I've explained it in much detail there. This one I'm just going to be a bit more straightforward. So first off, we know change in V is equals to V velocity at B minus velocity at A. Velocity at A plus change in velocity is going to be velocity at B. Okay, then we can just write it like this. So this is velocity at A, this is velocity at B. Now we can make a triangle out of this, and then the triangle will look something like this. This is going to be change in V. Okay, this is going to be the velocity at B. Remember to label your arrow's direction and what arrow represents what. Okay, so this is going to be the triangle, and then you have another triangle here as well, which is going to be this triangle. R change in theta, change in S, and this is also going to be change in theta. So we can say that change in theta is small, so change in theta is approximately equals to change in V over V. And then what we can say is that change in theta is going to be equals to omega change in t, and then we can say omega is equals to V over R. And then we can say that change in theta will be V over R times change in t. We can plug it in there. So V over R change in t is equals to change in V over V, and then V square over R is equals to change in V over change in t. And that's just the centripetal acceleration, which is V square over R. Okay, right. And remember one very important thing: when change in theta is small, we can assume the sector to be a triangle, and then we can use similar triangles. So I hope this is clear. This is 5 marks. Again, if I was a bit quick, you can go to the third exam walkthrough where I explain it much more slowly and explain a lot of things in much more detail. Okay, so I hope this is clear. Now let's go to the next part. So part B, the poi ball completes 1.3 revolutions per second. Calculate the centripetal acceleration of the poi ball. And they've given us the radius of the circular motion as 0.58 meters. So omega is equal to theta by t, and here 1.3 revolutions would be 1.3 times 2 pi divided by 1 second, and that's going to give me the value of omega. The value of omega will be 8.17 rad per second. Then we can plug this into the equation. Centripetal acceleration is r omega square. The radius is 0.58, and we can plug 8.17 square. And we get an answer of 38.7 meter per second square. Okay, now part C, it says the child comments that as the ball goes round the circle with a constant speed, the size of the force on the hand changes. To discuss whether this statement is correct. Now let's label the two forces. The first force is the weight of the poi ball, and the second force acting here is going to be the tension in the string. And we can see that there are two arrows. Now, the arrow that I'm going to circle is going to be the tension that's going to be acting on the hand. So the tension in the string is the force on the hand. Now we're going to write it down. So tension in the string or the cord is the force on the hand. And this is going to get us the first mark. The next point, which is very important, is weight and the centripetal force are constant. That's going to get us the second mark. So now that we have found the tension force is the force on the hand, we can see there's two situations. One where the poi ball is at the bottom of the circle and one where it's at the top. We can see when it's at the bottom, we have the tension force acting in the circle and weight acting out. And then when it's at the top, tension and weight both are acting in. The forces that are acting in are going to be positive, and the forces that are acting out are going to be assigned the negative. So this is how we do the directions in circular motion. So towards the center of the circle is going to be positive direction, and outside the circle, the forces pointing out of the circle are going to be negative. So that direction is basically the negative direction. So I hope that's clear. Now we can write the equation. So mv square over r is equals to tension minus weight for the bottom. And then we can make tension the subject. So we have mv square over r plus weight is equals to tension. And then we can do for the top, mv square over r is equals to tension plus weight. And then we can make t the subject, mv square over r minus weight is equals to tension. Now we can notice at the bottom we add weight, the top we subtract it. So tension is going to be different in both cases. Okay, so because of this, we can also say that at the bottom tension will be max, top it will be minimum. So we can write this down here, that at the top the weight is subtracted from the centripetal force, at the bottom it is added to the centripetal force to give the tension, therefore tension varies. So the student is correct in saying that the force on the hand changes. So that's going to give you the other 2 marks. So that's going to be the 4-mark answer. Hope that was clear. Now I'm going to show you the mark scheme and the examiner report.